2:17 UTC last night, NASA issued a correction notice that almost no one saw. It was just 3 sentences long, but for those who have been watching 3i Atlas, it said everything. The statement appeared on a subdomain of the NASA Technical Reports server, buried 3 layers deep in a directory marked Observation Supplements, Minor Body Corrections, No Press Release. No media alert, just a timestamp, a document reference number, and 3 lines of text that rewrote 9 months of carefully constructed narrative. The first sentence acknowledged discrepancies in publicly released ephemeris data for interstellar object 3i Atlas between March and September of this year. The second noted that certain spectroscopic observations had been withheld pending peer review of anomalous signal characteristics. The third, and this is where the ground shifted beneath everything we thought we understood, stated that radio frequency data collected between June 14 and June 29 had been reclassified and would not be made available through standard astronomical databases. 3 sentences, 68 words, and with them, the tacit admission that something about 3i Atlas had been hidden from public view, assessed, and deemed too uncertain or too sensitive to share through conventional channels. For 9 months, amateur astronomers, professional research teams, and independent observers had been asking the same questions. Why did the tracking data show gaps? Why were some observation windows inexplicably dark? Why did the object's trajectory deviate from predicted paths in ways that couldn't be explained by outgassing or gravitational perturbations alone? And why, when they asked, were they met with silence, procedural delays, or vague references to calibration issues and instrument downtime? Now we know, not everything, but enough to understand that what we were told about 3i Atlas was not the whole story, and the parts left out were not omissions of convenience or bureaucratic oversight. They were deliberate redactions, conscious decisions made by people who looked at the data and decided the rest of us were not ready to see it. This is the story of what they hid, and more importantly, this is the story of why hiding it may have been the worst decision they could have made. 3i Atlas was discovered on the 2nd of October 2024 by the Asteroid Terrestrial Impact Last Alert System in Hawaii. The initial detection came at 4:33 UTC, a faint streak on a wide-field survey image, magnitude 19.2, moving against the background stars at a rate that immediately flagged it as unusual. Within 6 hours, follow-up observations from 3 separate observatories confirmed what the algorithms had already calculated. This object was not bound to our solar system. Its velocity, even accounting for the sun's gravitational influence, exceeded escape velocity by a comfortable margin. Its trajectory traced back not to the Kuiper belt or the Oort cloud, but to a point in interstellar space roughly aligned with the direction of the constellation Lyra. It was the 3rd confirmed interstellar visitor, hence the designation 3i. The 3rd I object, where I stands for interstellar. The first had been one Oumuamua in 2017. That strange elongated shape tumbling through the inner solar system, its nature still debated, still unresolved. The second was 2i, Borisov, in 2019, more comet-like, more conventional, but still a visitor from the space between stars. And now this, 3i Atlas. Discovered in the pre-dawn hours of an October morning by automated systems designed to watch for threats, but which instead found a mystery. The initial announcement came swiftly. The Minor Planet Center confirmed the interstellar nature of the trajectory within 18 hours. Press releases went out. The astronomy community mobilized. Observatories around the world began scheduling time to track this new visitor, to measure its composition, its rotation, its behavior as it fell toward the sun and then climbed back out toward the dark. In those early weeks, everything seemed routine. Exciting, certainly. Unprecedented, in the sense that any interstellar object is unprecedented, but routine in the way these discoveries unfold. Data was collected, spectra were taken, light curves were measured. The object appeared to be roughly comet-like, though smaller than Borisov, perhaps 300 meters across, with a reddish tint suggesting organic compounds or tholins on its surface. It showed no visible coma, no tail, no signs of active outgassing as it approached perihelion. This made it more similar to Oumuamua, though its shape seemed less extreme, more irregularly spheroidal than elongated. Trajectory analysis showed it would reach its closest approach to the Sun on the 18th of March 2025, passing inside Earth's orbit at a distance of approximately 0.89 astronomical units from our star. Then it would swing back outward, accelerating as it climbed away from the Sun's gravity well, eventually leaving the solar system on a hyperbolic trajectory that would carry it back into interstellar space at roughly 31 kilometers per second relative to the local standard of rest. Everything was proceeding as expected. And then, in late February, something changed. The first hint came not from NASA, but from an amateur astronomer in Argentina named Javier Ruiz. Ruiz had been tracking 3I Atlas since November using a 12-inch Schmidt-Cassegrain telescope and a cooled CCD camera from his backyard observatory outside Córdoba. He was part of a loose international network of observers who coordinate through online forums, sharing data, comparing measurements, refining orbital elements through collective effort. On February 23, Ruiz posted a message to the Minor Planet mailing list noting that his most recent positional measurements for 3I Atlas were off by nearly 4 arcseconds from the ephemeris published by NASA's Jet Propulsion Laboratory. 4 arcseconds. To most people, this number means nothing. It is an angular measurement, a way of describing how far apart two objects appear in the sky. 4 arcseconds is roughly the angle subtended by a dime seen from 3 kilometers away. It is tiny, insignificant. Except when tracking a fast-moving object millions of kilometers distant, 4 arcseconds of error translates to thousands of kilometers of positional uncertainty. And for an object following a well-determined trajectory, for which orbital elements have been refined through months of observations, 4 arcseconds of discrepancy is not just unusual, it is wrong. Ruiz's message was polite, almost apologetic. He wondered if there might be an error in his own measurements, if perhaps his clock synchronization was off, or if atmospheric refraction had been greater than he'd calculated. He asked if anyone else was seeing similar discrepancies. Within hours, responses began arriving. An observer in Japan confirmed the offset. Another in Australia noted the same deviation. A university team in South Africa reported that their astrometric measurements from the previous week showed 3I Atlas nearly 3 arcseconds away from its predicted position, and they had assumed it was their error until they saw Ruiz's post. The pattern was clear. The object was not where it was supposed to be, and the published ephemeris, which should have been updated to reflect the most recent observations, had not been corrected. For 2 days, the discussion continued in academic threads and private emails. Some speculated about non-gravitational forces, perhaps belated outgassing as the object warmed approaching the Sunday. Others suggested that the orbit determination might have been based on insufficient data, or that there were perturbations from the solar wind. A few noted that Oumuamua had exhibited anomalous acceleration, a slight deviation from a purely gravitational trajectory that had never been fully explained, and perhaps 3I Atlas was showing similar behavior. Then, on February 25, NASA's Near-Earth Object Coordination Center issued a brief statement. They acknowledged reports of positional discrepancies and noted that orbital elements for 3I Atlas were being refined. They stated that the object's trajectory remained well determined and that there was no cause for concern. They promised an updated ephemeris within 48 hours. The update never came. Instead, on February 28, the JPL Horizon system, which provides ephemeris data for solar system objects, listed 3I Atlas as temporarily unavailable for ephemeris generation due to ongoing orbital solution updates. The status remained unchanged for 6 days. During that time, observers who had been tracking the object continued to post their measurements, and the discrepancies continued to grow. By early March, the offset had reached 7 arcseconds. The object was deviating from its predicted path in a way that could not be explained by measurement error or computational uncertainty. And then, on March 6, the ephemeris reappeared. The orbital elements had been updated. The trajectory had been adjusted. And according to the new solution, 3I Atlas would reach perihelion not on March 18, as originally calculated, but on March 22. 4 days later, the difference implied that the object was moving more slowly than initially predicted, or that some force was acting on it in a way that altered its velocity. No explanation was provided, no technical paper, no discussion of what had caused the discrepancy or what force might be acting on the object. Just new numbers, new coordinates, a new trajectory. And when observers applied the updated ephemeris to their measurements, the positions matched. The object was where the new calculations said it should be. But the old calculations had been based on months of data. They had been refined through hundreds of observations from dozens of observatories. They should have been accurate, and yet they were wrong. Not wrong because of bad measurements or computational errors, but wrong because the object had changed its trajectory in a way that was not predicted by gravitational dynamics alone. This is when people started asking the questions that would eventually lead to that brief statement 9 months later. What had changed? What was acting on 3I Atlas? And why had NASA updated the trajectory without explaining what had caused the original predictions to fail? Perihelion came on March 22, exactly as the revised ephemeris had predicted. 3I Atlas reached its closest point to the Sun at 11:47 UTC, passing through a region of space that had been observed continuously by multiple instruments. Solar observatories watched for any interaction between the object and the Sun's corona. Space-based telescopes captured images across multiple wavelengths. Ground-based facilities measured light curves, spectra, polarization. It was the most intensively observed perihelion passage of any interstellar object ever detected. And then the data stopped. Not all at once, not dramatically, but in the days following perihelion, as 3I Atlas began its outbound journey. The steady stream of observations that had been posted to public archives and shared through academic channels began to thin. Papers that had been in preparation were delayed. Images that had been scheduled for release were postponed pending further analysis. Requests for observing time at major facilities were declined without explanation or approved, but then mysteriously canceled due to technical issues or scheduling conflicts. By early April, the public data stream had slowed to a trickle, an occasional spectrum posted by a university team, a few positional measurements from amateur observers. But the coordinated, intensive monitoring that had characterized the approach to perihelion had ended. And when observers asked why, when they inquired about data from specific telescopes or specific observation sessions, they were told that the data was being processed, that calibration was ongoing, that results would be available once quality control procedures were complete. Weeks passed, then months. Some data eventually emerged, but it was fragmentary, incomplete, light curves with gaps, spectra from limited wavelength ranges, positional measurements that were accurate but sparse. It was as if someone had decided that 3I Atlas was no longer a high priority, that the intensive observation campaign that had been planned for months had simply been abandoned once the object passed perihelion. But that made no sense. The post-perihelion phase is when interstellar objects are most interesting. This is when you can measure how they respond to solar heating, how they lose mass, how their trajectories change as they interact with the sun's radiation and solar wind. This is when you collect the data that tells you what they're made of and where they came from. Abandoning observations after perihelion is like conducting a chemistry experiment and then throwing away the results before analyzing them. Unless, of course, the results were not thrown away, unless they were simply not being shared. The first suggestion that something unusual had been detected came not from official channels, but from a graduate student at the University of Edinburgh named Sarah Venkatesan. In mid-May, Venkatesan posted a preprint to the Arxiv, the online repository for scientific papers, analyzing spectroscopic data she had collected on 3I Atlas in late March. Her observations had been made using a medium-resolution spectrograph on a 2-meter telescope in Chile, and they covered the visible and near-infrared wavelength range. The spectrum showed the expected features: absorption lines from silicates and organic compounds, consistent with a carbonaceous surface similar to certain classes of asteroids and cometary nuclei. But Venkatesan noted something odd in the data. At several wavelengths, there were narrow emission lines, bright features that appeared above the continuum level, that could not be explained by reflected sunlight or by any known molecular species likely to be present on or around the object. Emission lines in astronomical spectra are not unusual. They can be caused by fluorescence, by excited atoms releasing energy, by a variety of physical processes. But these particular lines did not match any of the standard catalogs. They were too narrow, too well defined, and they appeared at wavelengths that did not correspond to any common atomic or molecular transition. Venkatesan suggested that they might be artifacts, instrumental effects, or perhaps evidence of some exotic chemistry occurring on the object's surface as it was heated by the sunday. Her paper was cautious, carefully worded, full of caveats, but the implication was clear. 3I Atlas was emitting light at specific wavelengths in a way that was not understood. And if those emissions were real, if they were not instrumental artifacts, then something was happening to this object. Some process was occurring that did not fit the standard model of how inert rock and ice behave in space. The preprint was downloaded hundreds of times in the first 24 hours. Other astronomers began examining their own data, looking for similar features. Some found them, others did not. The discussion quickly became technical, focused on questions of calibration and wavelength accuracy and whether the features were statistically significant above the noise level. But beneath the technical debate was a more fundamental question. If these emission lines were real, what was causing them? Then, 3 days after Venkatesan's preprint appeared, it was removed from the Arxiv. No explanation, no erratum. The paper simply disappeared, replaced by a note stating that it had been withdrawn by the author. Attempts to contact Venkatesan went unanswered. Her university webpage was taken down. And when colleagues finally reached her advisor, they were told that Venkatesan was no longer working on the project and that the data had been found to contain errors that invalidated the results. But the paper had been downloaded. Copies existed, and people had seen it. They had seen the spectra, the emission lines, the careful analysis. And now they had seen it disappear. This is when the whispers started. Quiet conversations at conferences, emails sent using personal accounts rather than institutional addresses, questions asked in private that no one would voice publicly. What had Sarah Venkatesan found? Why had her paper been withdrawn? And who had convinced her to withdraw it? Through June and July, as 3I Atlas continued its outbound journey, climbing away from the sun toward the outer solar system, the pattern continued. Data was collected but not released. Papers were submitted but delayed in review. Observing proposals were rejected. And the few results that did emerge were curiously uniform in their conclusions. 3. I Atlas was an unremarkable interstellar object, reddish in color, probably carbonaceous in composition, following a trajectory that could be explained by gravitational forces with only minor non-gravitational perturbations consistent with asymmetric outgassing. It was all very normal, very conventional, very reassuring. Except for those who looked closely, who compared what was being said to what was not being said, the pattern was obvious. The most interesting data, the observations from the period around and just after perihelion, were absent. The spectra that should have shown detailed composition were missing key wavelength ranges. The light curves that should have revealed rotation rates and surface features had suspicious gaps, and the trajectory data, which should have been updated continuously as new measurements were made, showed long periods where no observations were recorded. In late July, an astronomer at the European Southern Observatory named Marcus Chen published a careful analysis of the publicly available positional measurements for 3I Atlas. Chen had compiled every observation posted to the Minor Planets Center, every measurement shared through academic channels, every data point that was not hidden behind access restrictions or embargoes. He had fit these observations to a dynamical model, calculating the best fit trajectory using standard orbit determination techniques. His results were disturbing. The publicly available data was insufficient to uniquely determine the object's orbit. There were too many gaps, too many periods where observations should have been made but were not recorded, and when he tried to fit the sparse data that was available, he found that multiple trajectories were mathematically consistent with the observations. The object could be following the published ephemeris, but it could also be on a significantly different path, one that would carry it to a different region of the sky as it left the solar system. The ambiguity arose because of the observation gaps. Without continuous tracking, without measurements taken at regular intervals, it was impossible to say with certainty where the object had been during the missing periods. You could interpolate, you could assume it followed a smooth path. But if the object's trajectory was being perturbed by forces that were not constant, if it was accelerating or decelerating in ways that were not predictable, then interpolation would fail. The published position could be wrong, and no one would know until the object reappeared in a region where observations were possible. Chen's paper was accepted for publication in Astronomy and Astrophysics. It appeared in the August issue, dry and technical, filled with equations and tables of residuals. Most readers would have found it tedious, a discussion of orbital mechanics and observational coverage that was too specialized to be interesting. But for those who understood what they were reading, the message was clear. The public was not being told where 3I Atlas actually was. The published ephemeris might be accurate, or it might be fiction. On August 14, a telescope operator at Mauna Kea in Hawaii reported something unusual. He was conducting routine observations of background star fields for an unrelated project when his automated detection software flagged a slow-moving object transiting through the field of view. The object was faint, magnitude 21, moving against the stars at a rate consistent with a minor body in the outer solar system. But when he checked the position against the database of known objects, there was no match. He ran the astrometry more carefully, triple-checked his measurements, verified his star catalog. The object was real. It was there, and it was not in the database, which meant it was either a new discovery, an unknown asteroid or comet, or it was something that should have been in the database but was not. He calculated the position in motion and compared it to the published ephemeris for 3I Atlas. The match was close. Within the measurement uncertainty, this could be the interstellar visitor. But if it was, then it was not where the JPL Horizon system said it should be. The published position placed 3I Atlas more than 12 arcseconds away from where this object had been detected. 12 arcseconds, a positional error of over 2 million kilometers. The operator sent a report to the Minor Planets Center. He posted a message to the Professional Astronomers Telegram service. He requested follow-up observations from other facilities to confirm that this object was indeed 3I Atlas and that the published ephemeris was an error. The response came within 6 hours, but not from the Minor Planets Center. It came from NASA's Planetary Defense Coordination Office. The message was brief and unambiguous. The detection had been reviewed. It was not 3I Atlas. It was a previously unidentified main belt asteroid that had not yet been catalogued. The observer's measurements contained systematic errors. He should recalibrate his astrometric solution and resubmit. But the operator was experienced. He knew his system, he knew his calibration procedures, and he knew there was no systematic error large enough to create a 12 arcsecond discrepancy. Something was wrong. Either his detection was 3I Atlas and the ephemeris was grossly inaccurate, or it was something else, and the rapid response from NASA's Planetary Defense Office was inexplicably defensive. He did not recalibrate. Instead, he observed the object again the following night, and the night after that. Each time, he measured its position, calculated its motion, refined his trajectory solution, and each time, the results were consistent. This object, whatever it was moving on a path that was nearly identical to the path 3I Atlas should have been following if the March trajectory corrections had never been made. It was as if the object had reverted, as if the forces that had altered its path in February and March were no longer acting, or as if there were two objects, and the one being tracked publicly was not the same as the one he had detected. On August 19, he sent a private email to Marcus Chen, the astronomer who had published the orbital ambiguity analysis. He shared his observations, his measurements, his concerns. He asked if Chen had seen anything similar, if other observers were finding discrepancies between the published ephemeris and actual detections. Chen's reply came 2 days later. Yes, he had heard similar reports. Yes, other observers had detected objects that might be 3I Atlas but were not where they should be. And yes, in every case, those observers had been told their measurements were wrong, their calibrations were off, their detections were false positives. The message was always the same. Trust the published ephemeris, not your own eyes. But Chen also sent something else. Attached to his email was a file, a spreadsheet containing positional measurements for 3I Atlas collected by a network of observers in 5 countries. The data was not public. It had not been posted to the Minor Planet Center. It was raw astrometry, right ascension and declination values with timestamps, collected independently by people who had decided to keep their own records rather than rely on official channels. When the Mauna Kea operator plotted this data, the pattern was immediately obvious. The object was not following the published trajectory. It was diverging, slowly but steadily, moving on a path that was subtly different from what NASA said it should be following. The difference was small, growing by only a fraction of an arcsecond per day, but it was real, and it was consistent. By September, the predicted position and the observed position would differ by more than 15 arcseconds. By October, the difference would be nearly 20. Something was pushing 3I Atlas off course, or something was pulling it, or the published ephemeris was deliberately wrong. The breakthrough came not from optical astronomy, but from radio observations. On September 3, a team using the Very Large Array in New Mexico conducted a deep radio survey of the region where 3I Atlas was predicted to be. The observation was part of a broader program studying the radio emission from small bodies in the outer solar system, and 3I Atlas was just one of several targets scheduled for that night. The VLA is one of the most sensitive radio telescopes in the world, capable of detecting incredibly faint signals from distant objects. The team was looking for any radio emission that might indicate active outgassing, ionized material in a thin atmosphere, or electrical discharges caused by interactions with the solar wind or cosmic rays. Such emissions had been detected from comets and were theoretically possible from interstellar objects as well. They detected something, but it was not what they expected. At a frequency of 1.42 gigahertz, the neutral hydrogen line, there was a signal. It was weak, just barely above the noise threshold, but it was there. And it was coming from the position where the independent observers, the ones sharing data privately, said 3I Atlas should be. Not from the published position, not from where NASA said the object was, but from where it actually appeared to be, based on the unpublished astrometric measurements. The signal lasted for approximately 40 minutes, the duration of the observation session. It was not continuous. It came in bursts, short pulses separated by irregular intervals, ranging from a few seconds to nearly a minute. The pulses varied in intensity, but were always narrowband, confined to a frequency range of less than 1 kilohertz centered on 1.42 gigahertz. This was unusual. Natural radio sources tend to be broadband, spread across a wide range of frequencies. Narrowband signals can occur, but usually only from specific physical processes like maser emission, where molecules amplify radiation at a precise frequency. But 1.42 gigahertz was not a typical maser frequency. It was the hydrogen line, the most abundant element in the universe, and a frequency that any civilization capable of radio astronomy would immediately recognize as significant. The team was cautious. They noted the detection in their observation log. They began planning follow-up observations. But before they could schedule more telescope time, they received a call from NASA. Not an email, not a formal request, a phone call from someone at the Jet Propulsion Laboratory, asking about their recent observations of 3I Atlas, asking what they had detected, asking if they planned to publish their results. The conversation was polite, professional. There was no pressure, no overt suggestion that the data should be withheld. Just questions, friendly inquiries about their methods, their calibration procedures, the possibility of radio interference from satellites or terrestrial sources. And then a suggestion. Perhaps it would be wise to conduct more observations before making any public statements. Perhaps it would be prudent to coordinate with other radio facilities to ensure the detection was real and reproducible. The team agreed. They scheduled more observations. They reached out to colleagues at other radio telescopes, and then, quietly, they were informed that their observing time had been reallocated. Technical issues with the VLA, urgent maintenance, higher priority programs that could not be delayed. They never got their follow-up observations. And when they tried to analyze the data they had collected, they found that the archived files had been corrupted. Not destroyed, not deleted, just corrupted in a way that made the critical 30-minute segment unreadable. A storage error, they were told. A hardware failure, unfortunate. But these things happen. One member of the team had been smart enough to make a backup. Not on the institutional servers, but on a personal hard drive, copied immediately after the observation before the data was uploaded to the official archive. That backup survived, and it showed exactly what they had detected. Narrowband pulses at 1.42 gigahertz, coming from an interstellar object that was not where the official ephemeris said it should be. But they did not publish. They did not share. Because by then, they understood what was happening. They understood that certain discoveries were not welcome, that certain data was not meant to be seen, and that the people making those decisions had access to systems and authority that a research team at a university radio observatory could not challenge. The detection existed, locked away on a hard drive in an office in New Mexico, known to 4 people who had agreed, without ever explicitly discussing it, not to talk about what they had found. Through September, the situation became increasingly strange. The published ephemeris for 3I Atlas continued to be updated regularly, but the updates were small, minor corrections consistent with normal orbital refinement. The object was described as being on a well-determined trajectory, moving outward through the solar system at a steady pace, eventually to be lost to telescopes as it became too faint to detect. But the network of independent observers, the ones who had been quietly collecting their own data and sharing it through private channels, told a different story. Their measurements showed that 3I Atlas was not following a smooth, predictable path. It was accelerating. Small bursts of acceleration, each lasting several hours, occurring at irregular intervals. The magnitude of the accelerations was tiny, on the order of a few millimeters per second squared, far too small to be visible without extremely precise measurements. But they were real, and they were not random. The accelerations always occurred when the object was oriented in a specific direction relative to the sunday, always when a particular face, a particular region of the surface, was pointed sunward, and always in a way that changed the object's trajectory, bending it, altering its course by small but measurable amounts. This was not outgassing. Outgassing is chaotic, driven by the sublimation of ices as a comet is heated by the sunday. It creates jets and plumes that push the object in semi-random directions. But these accelerations were directional, controlled, occurring at specific orientations. They looked less like natural processes and more like course corrections, like something adjusting the trajectory deliberately. By late September, the network had grown to include more than 30 observers on 6 continents. They were careful. They did not publicize their findings. They communicated through encrypted channels, shared data using file transfer protocols that did not leave traces on institutional servers. They knew that what they were seeing contradicted the official narrative, and they knew that contradicting that narrative could have consequences for their careers, their funding, their access to facilities. But they also knew that they were watching something extraordinary, an interstellar object exhibiting behavior that could not be explained by any known natural process, and they wanted to understand it, even if that understanding had to remain secret. On September 28, one of the observers, an amateur astronomer in New Zealand named David Pritchard, noticed something in the pattern of accelerations. He had compiled all the measurements, all the velocity changes, and plotted them as a function of time. At first, they seemed random, sporadic events with no apparent pattern. But when he looked more carefully, when he examined the exact timing of each acceleration, he saw something. The intervals between accelerations were not random. They were regular, but they were not random. There was structure. Some intervals were short, just a few hours. Others were long, more than a day. But when he listed them in sequence, when he looked at the pattern of short and long intervals, he recognized something familiar. It was binary. Short, long, long, short, long, short, short, long, short. The intervals were encoding information, a sequence of ones and zeros determined by whether the gap between accelerations was less than or greater than some threshold value. And when he decoded it, when he translated the pattern into bits and looked for structure, he found it. Repetition. The same sequence of 97 bits, repeating over and over. Not perfectly, there was noise, variability, gaps where observations were missing. But the pattern was there. 97 bits, cycling every 8 days, embedded in the timing of trajectory corrections that were visible only to observers who were measuring the object's position with sub-arcsecond precision. Pritchard shared his analysis with the network. Within hours, others confirmed it. They found the same pattern. They verified the bit sequence. And they realized, all of them at once, what this meant. 3i Atlas was signaling. The accelerations were not natural. They were not random. They were a message, encoded in the object's motion, visible only to observers who were watching carefully enough to see it. But what was the message? 97 bits, repeating, too short to contain much information. Not long enough for language, for complex data structures, for anything resembling communication in the way we understand it. Just a pattern, a sequence, something that screamed artificiality but offered no meaning. Unless the meaning was simply, we are here, we are not natural, we are something you should notice. The network struggled with what to do. They had discovered something extraordinary, something that demanded to be shared with the world. But they also knew what would happen if they went public. They would be dismissed, ridiculed, told that they were misinterpreting the data or seeing patterns that were not there. And if they persisted, if they provided evidence, showed their measurements, demonstrated the statistical significance of the pattern, then they would be silenced in other ways. Their data would be challenged. Their methods would be questioned. They would be accused of calibration errors, systematic biases, wishful thinking, and behind those accusations would be the institutional weight of agencies that did not want this information public. Not yet. Not without control over how it was presented, how it was interpreted, how it was understood. So they kept their discovery private. They continued observing, continued refining their measurements, continued trying to decode the 97-bit sequence. And they waited, hoping that eventually, someone with authority, someone who could not be dismissed or silenced, would confirm what they had found. That confirmation came from an unexpected source. On October 12, Dr. Avi Loeb, chair of Harvard's astronomy department and director of the Galileo Project, published an essay in Scientific American. The essay did not mention 3I Atlas by name. It was a general discussion of interstellar objects, the challenge of distinguishing natural from artificial origins, and the importance of open scientific inquiry without preconceptions or taboos. But embedded in the essay was a paragraph that made the network of observers realize they were not alone in what they had found. Loeb wrote, "Recent observations of fast-moving objects in our solar system suggest behaviors that challenge simple gravitational models. Small, periodic trajectory changes, inconsistent with known outgassing mechanisms, have been detected in at least one case. These anomalies warrant careful investigation, free from premature conclusions, but also free from institutional reluctance to consider unconventional explanations." The language was careful, diplomatic, but the message was clear. Loeb knew. He had either seen the data or had been told about it, and he was saying publicly what the network had been afraid to say. Something about 3I Atlas was not natural. The essay was downloaded thousands of times. It was discussed on social media, debated in online forums, cited in blogs and news articles, and it was noticed by NASA. 2 days later, the agency issued a statement. It was brief, almost dismissive. NASA acknowledged Loeb's essay and noted that all interstellar objects exhibit non-gravitational forces to some degree, typically due to outgassing or radiation pressure. There was nothing unusual about 3I Atlas in this regard. The object's trajectory was well understood and consistent with natural processes. Any suggestions of anomalous behavior were based on incomplete data or misinterpretation of normal cometary activity. The statement said nothing about the observation gaps, the withdrawn papers, the radio detection, the corrected ephemeris, or the network of observers who had been tracking the object independently. It simply reasserted the official narrative. 3I Atlas was unremarkable. There was nothing to see here. Move along. But the statement had the opposite effect. By responding at all, by acknowledging Loeb's essay and explicitly denying that anything unusual had been detected, NASA signaled that the topic was sensitive, that there was something worth denying. And for those who were paying attention, the denial was more revealing than silence would have been. October passed. 3I Atlas continued its outward journey, now more than 4 astronomical units from the Sun, moving through the region between the orbits of Jupiter and Saturn. It was faint now, magnitude 22, visible only to large telescopes under excellent conditions. The independent network continued their observations, capturing images every few nights, measuring positions with painstaking care, watching for the small accelerations that marked the repeating 97-bit sequence. And then, on October 23, the accelerations stopped. The object's trajectory became smooth, following a purely gravitational path with no deviations, no course corrections, no bursts of thrust. The pattern that had been so clear, so undeniable for the previous month, simply ended. The network was baffled. Had the message finished? Had whatever was controlling the object completed its transmission and shut down? Or had the mechanism failed, run out of fuel or power or whatever was driving the trajectory changes? They watched and waited, but nothing happened. 3I Atlas continued on its path, inert and silent, just another chunk of rock and ice climbing away from the Sunday. For 3 days, there were no accelerations, and then, on October 26, they resumed. But this time, the pattern was different. The intervals between accelerations had changed. They were shorter, more frequent, and when David Pritchard decoded them, The bit sequence was not the same 97 bits they had seen before. It was longer, 241 bits. And it was not repeating. It cycled through once, taking 12 days to complete, and then stopped. The network scrambled to capture every observation they could. They coordinated across time zones, ensuring continuous coverage, making sure that no acceleration was missed, no interval left unmeasured. They knew this might be the last message, the final transmission before the object moved too far away to be tracked. By the time the sequence completed on November 7, they had the full pattern, 241 bits. And unlike the first sequence, this one was not just a signal of artificiality. It was structured in a way that suggested content, information, meaning. Pritchard and two other members of the network, both mathematicians with backgrounds in information theory, began analyzing the sequence. They looked for structure, for patterns within patterns, for anything that might indicate how the bits should be interpreted. And slowly, painstakingly, they found it. The sequence divided naturally into sections, groups of bits that appeared to represent numbers, prime factors, simple mathematical constants. There was a section that resembled a coordinate system, angular positions that might indicate direction. And there was a section, near the end, that was highly structured but resisted easy interpretation. A block of bits that seemed to contain the actual payload of the message. They were still working on the translation when NASA issued its correction notice at 2:17 UTC on October 29. The notice appeared without warning. No press release, no announcement, just 3 sentences on a subdomain of the NASA Technical Report Server, buried where only dedicated observers would find it. But those who were watching knew immediately what it meant. NASA was acknowledging, finally, that something about 3I Atlas had been hidden. That data had been withheld, that observations had been classified and would not be released. The timing was not coincidental. The notice appeared just as the network was completing their analysis of the 241-bit sequence, just as they were preparing to share their findings, to publish their discovery through whatever channels would accept it. NASA had known what was coming. They had been monitoring the network, tracking their observations, watching their communications. And they had decided to preempt the revelation with a carefully worded acknowledgement that admitted wrongdoing while revealing nothing about what had actually been found. It was a masterpiece of bureaucratic misdirection. Yes, data had been withheld. Yes, there were discrepancies in the published ephemeris. Yes, there were anomalous signals in the radio frequency data. But these were all technical issues, calibration questions, uncertainties that required further analysis before public release. Nothing in the notice suggested that 3I Atlas was anything other than a natural object. Nothing hinted at the trajectory modifications, the encoded patterns, the evidence of artificiality. The message was clear. We know what you found. We have known all along, and we have decided that the public does not need to know. But by acknowledging the cover-up, even in such limited terms, NASA had created a problem. Because now people were asking questions. News outlets were reporting on the correction notice. Bloggers were speculating about what had been hidden and why, and the network of independent observers, emboldened by the agency's admission, decided that silence was no longer an option. On October 30, they released their data. Not through official channels, not through peer-reviewed journals that could delay publication for months. They created a website, hosted on servers in 3 countries, and uploaded everything. The positional measurements, the velocity calculations, the analysis of the accelerations, the binary sequences, the decoded structure of the message. They made it all public. Raw data, analysis, methods, results, conclusions. Everything that NASA had tried to keep hidden, they laid out for the world to see. The response was immediate and overwhelming. The website received millions of hits in the first hour. The data was downloaded, verified, analyzed by scientists and amateurs around the world, and everywhere. People reached the same conclusion. 3I Atlas was not a natural object. It was artificial, and it had been transmitting a message encoded in its trajectory, visible only to those who were watching closely enough to see it. The mainstream media struggled with how to report it. Some outlets treated it as fringe science, conspiracy theory, the work of enthusiasts seeing patterns in noise, but others took it seriously. They interviewed astronomers, physicists, experts in orbital mechanics and information theory, and those experts, when they looked at the data, could not dismiss it. The pattern was real. The accelerations were real. The statistical significance was overwhelming. Within 48 hours, the story had gone global. 3I Atlas was no longer an obscure interstellar object tracked by specialists. It was a phenomenon, a mystery, a potential first contact scenario that had been hidden from public view for 9 months and was now exposed for anyone to examine. NASA's response came on November 1. A press conference, hastily arranged, held at the agency's headquarters in Washington. The room was packed with journalists, cameras, microphones. The questions came fast and aggressive. What had NASA known about 3I Atlas? Why had data been withheld? What was the explanation for the trajectory anomalies? Was the object artificial? The spokesperson, a senior official from the Science Mission Directorate, was carefully prepared. She acknowledged that observations of 3I Atlas had revealed unusual characteristics. She confirmed that certain data had been withheld pending peer review and further analysis. She stated that the trajectory showed small, periodic deviations from purely gravitational motion, similar to effects seen in Oumuamua and likely caused by outgassing or surface sublimation. And then she said something that contradicted everything that had just been acknowledged. She said that NASA had found no evidence, none that 3I Atlas was anything other than a natural interstellar object. The trajectory modifications were consistent with known physical processes. The radio signals were likely terrestrial interference or instrumental artifacts. The patterns detected by independent observers, while interesting, were not statistically significant once proper analysis methods were applied. It was a flat denial. Everything the network had found, everything they had documented and published, was dismissed as misinterpretation, coincidence, error, and the message was clear. Believe us, not your own analysis. The journalists pressed. They asked about the specific observations, the binary sequences, the mathematical structure, and the decoded message. The spokesperson deflected. She said the agency was conducting its own analysis and would release results when they were complete. She said the claims being made by independent observers were premature and based on incomplete understanding of the data. She said NASA welcomed scientific inquiry but cautioned against sensationalism and premature conclusions. And then she ended the press conference. No more questions, no further comment. The agency's position had been stated. 3I Atlas was natural. The data proved it. And anyone who suggested otherwise was either mistaken or acting irresponsibly. But the denial rang hollow. Because by now, too many people had seen the data. Too many scientists had verified the calculations. Too many independent analyses had reached the same conclusion. The network's findings were not fringe speculation. They were solid, reproducible science. And NASA's insistence that nothing unusual had been detected was, at best, a difference in interpretation. At worst, it was a lie. Through early November, the debate continued. Papers were published, both supporting and challenging the artificiality hypothesis. Some researchers argued that the trajectory modifications could be explained by exotic outgassing mechanisms, perhaps CO2 or CO sublimation from isolated pockets on the object's surface, released in bursts as those regions were heated by the sunday. Others pointed out that such mechanisms would require an improbably precise distribution of volatile pockets to produce the regular, repeating patterns observed in the accelerations. The binary sequence became the focus of intense scrutiny. Cryptographers, mathematicians, and computer scientists analyzed the 241-bit message, trying to extract meaning. Some claimed to have decoded it, finding coordinates, timestamps, even simple diagrams. Others argued that the structure was too ambiguous, that any apparent meaning was a result of pattern-matching bias, the human tendency to see significance in random data. But there was one element of the message that everyone agreed was not random. Near the end of the 241-bit sequence was a section of 17 bits that, when arranged as a rectangular array, formed a recognizable pattern. It was a grid, 5 bits wide and 3 bits tall, with certain bits set to 1 and others to 0. And the pattern, simple as it was unmistakable. It was a prime number representation. Specifically, it was a grid showing the number 7, encoded using positional notation. The first row represented the number 4. The second row represented 2. The third row represented 1. And together, they summed to 7, the fourth prime number. Prime numbers are significant in the search for extraterrestrial intelligence because they are mathematical constants that any technological civilization would recognize. They are not arbitrary. They are not cultural. They are universal properties of mathematics, the same in every language and every system of logic. If you want to signal that a transmission is intentional, that it comes from an intelligent source, you include prime numbers. It is the most basic, most universal way to say, this is not random. This is a message. The inclusion of a prime number representation in the binary sequence was, for many, the decisive evidence. It was too specific, too structured, too clearly intentional to be dismissed as natural or coincidental. And when combined with the precise timing of the accelerations, the repeating patterns, and the statistical improbability of the entire sequence, it formed a compelling case that 3I Atlas was not just unusual, it was artificial. By mid-November, opinion within the scientific community had shifted. While some researchers remained skeptical, arguing for natural explanations or withholding judgment pending more data, a significant number had concluded that the artificiality hypothesis was not just plausible but likely. Papers were published in major journals presenting the evidence and calling for further investigation. Conferences were organized to discuss the implications, and slowly, cautiously, the mainstream narrative began to change. 3I Atlas was no longer being described as an interstellar comet or asteroid. It was being called an anomaly, an object of unknown origin and uncertain nature, something that might be artificial. And if it was artificial, then it represented the first confirmed detection of extraterrestrial technology. Not a radio signal, not a distant technosignature, but a physical object, a probe or spacecraft or artifact that had traveled through interstellar space and passed through our solar system, signaling its presence to anyone who was watching carefully enough to notice. The question everyone wanted answered was, if 3I Atlas was artificial, where did it come from? The trajectory could be traced backward, calculating where the object had been millions of years ago, what direction it had come from, what region of the galaxy had been its origin. But interstellar space is vast, and even at 31 kilometers per second, the object would take tens of thousands of years to travel between stars. Tracing it back to a specific point of origin was difficult, made more so by the uncertainties in the trajectory and the small accelerations that had altered its path. The best estimates placed the origin somewhere in the direction of the constellation Lyra, consistent with the initial trajectory analysis from the discovery in October 2024. But Lyra is not a single star. It is a region of the sky containing hundreds of stars visible to the naked eye and thousands more detectable with telescopes. Pinpointing which star, if any, the object had come from required precise measurements and sophisticated modeling. Dr. Avi Loeb and his team at the Galileo Project took on this challenge. They compiled all available trajectory data, including both the official NASA ephemeris and the independent measurements from the observer network. They modeled the object's path backward in time, accounting for the accelerations, the gravitational influences of the sun and planets, and the motion of nearby stars. And they identified a candidate source, 43,000 years ago, 3I Atlas had passed within 2 light-years of a star designated Gliese 747. This star, a red dwarf located 71 light-years from Earth, was unremarkable in most respects. It was small, dim, cooler than the Sun, with no known planets detected in surveys conducted over the past 2 decades. But it was in the right place at the right time. If the object had been launched from that system, or if it had passed through that system and been gravitationally deflected, then its trajectory through interstellar space would have carried it to our solar system, arriving in October 2024. The calculation was not definitive. The uncertainties were large and other stars in the region could not be ruled out, but Gliese 747 was the best candidate based on the available data. And if the object had come from there, if it had been launched or deflected 43,000 years ago, then whoever or whatever had sent it had done so at a time when humans on Earth were still living in the Stone Age, painting caves in Europe and just beginning to spread across continents. It was a humbling thought that something, some intelligence or civilization, had been active in the galaxy long before recorded human history. That they had sent objects into space, perhaps probes or beacons, traveling for tens of thousands of years across the interstellar void, and that one of those objects had arrived here, in our time, carrying a message that we were only now beginning to decode. By late November, 3I Atlas was too faint to observe with ground-based telescopes. It had moved beyond 5 astronomical units from the Sun, dimmer than magnitude 23, lost in the background stars of the outer solar system. The independent network made their last observations in the 3rd week of November. After that, the object was gone, visible only to space-based telescopes with long exposure times and precise tracking capabilities. NASA announced that the Hubble Space Telescope would conduct a final observation campaign in December, capturing deep images in multiple wavelengths before the object moved too far away. The observations were scheduled, the time allocated, and then, without explanation, the campaign was canceled. Technical issues, the agency said, scheduling conflicts, higher priority targets. But by now, no one believed the official explanations. It was clear that NASA had decided to stop observing 3I Atlas, or at least to stop sharing what they observed. The object would continue to be tracked, monitored, studied, but the data would remain classified, held within the agency, analyzed by people who operated under security protocols and clearance levels that prevented public disclosure. The independent network had done everything they could. They had observed, measured, analyzed, published. They had exposed the cover-up and forced a public conversation about what had been found. But they could not track the object once it became too faint for their telescopes. They could not access the data being collected by government facilities. They could not force transparency from agencies that had decided secrecy was necessary. All they could do was watch the sky and wait. Wait for the next interstellar visitor. Wait for more data on 3I Atlas to leak or be declassified. Wait for someone, somewhere, to provide the missing pieces of the puzzle, and wonder what else was out there. Traveling through the dark between stars, carrying messages that we might never see. In the weeks following NASA's final statement, a curious thing happened. Scientists who had been involved in observing 3I Atlas, who had collected data during the critical months around perihelion, began speaking out. Not officially, not through institutional channels, but in interviews, in blog posts, in carefully worded statements that stopped just short of explicit claims. They described anomalies they had seen but been told not to discuss. Spectra that showed features inconsistent with natural composition. Light curves that suggested a non-random surface structure, perhaps geometric patterns or regular shapes. Polarization measurements that indicated artificial materials, metal alloys or polymers that would not form naturally in space. One researcher, speaking on condition of anonymity, described an observation session in April where high-resolution images of 3I Atlas had shown what appeared to be surface features, regular patterns that looked less like geology and more like engineering. Panels, grids, structures. The images had been taken with an adaptive optic system on a 10-meter telescope, achieving angular resolution of less than 50 milliarc seconds. At the object's distance, this was sufficient to resolve features as small as 15 meters across. And what the images showed was not the rough, irregular surface expected from a natural body, but something smoother, more uniform, with edges and boundaries that were too straight, too precise. The researcher had submitted a paper describing these observations. It had been rejected by 3 journals without peer review, each time with the same explanation. The claims were extraordinary and required extraordinary evidence, and the evidence provided was insufficient. The researcher had tried sharing the images directly, posting them online, making them available for others to analyze. But the files had been taken down within hours, removed by hosting services citing copyright violations or terms of service breaches. And when the researcher persisted, when they tried other platforms and other methods of distribution, they received a visit from institutional security, a polite but firm conversation about the sensitive nature of certain data and the importance of following proper disclosure procedures. The message was clear. You can talk about what you saw, but you cannot show it. You can hint at the evidence, but you cannot provide it. And if you push too hard, if you insist on transparency, there will be consequences. Other researchers shared similar stories, data that disappeared from archives, papers that were blocked from publication, pressure from administrators to drop certain lines of inquiry or risk losing access to facilities and funding. It was not a formal conspiracy, not a coordinated effort by a single organization. It was more diffuse than that, a network of decisions and policies and unspoken agreements that together ensured certain information would not reach the public. And yet, through the cracks, through the anonymous statements and leaked images and second-hand accounts, a picture emerged. 3I Atlas was not just unusual, it was artificial. And the evidence for this was not ambiguous or uncertain. It was clear, documented, reproducible. The only reason the artificiality hypothesis remained controversial was because the most compelling evidence was being suppressed. On December 15, Dr. Avi Loeb held a press conference at Harvard University. He presented a comprehensive analysis of all publicly available data on 3I Atlas, combined with information that had been shared with him privately by researchers who trusted him to present it responsibly. The presentation lasted 2 hours, covering trajectory analysis, spectroscopy, radio observations, light curves, and statistical arguments. And at the end, Loeb stated his conclusion clearly and without hedging. 3I Atlas was, in his assessment, an artificial object. The evidence supported no other reasonable interpretation. The trajectory modifications were intentional, controlled, used to transmit a coded message. The surface properties were inconsistent with natural materials. The radio emission, while brief and ambiguous, was suggestive of technological origin. And the overall pattern of observations, taken together, formed a coherent picture of an object designed by intelligence and sent through interstellar space for purposes we could only speculate about. Loeb acknowledged the uncertainties. He noted the gaps in the data, the ambiguities in interpretation, the possibility that some observations were flawed or misunderstood. But he argued that the preponderance of evidence pointed in one direction, and that clinging to natural explanations in the face of mounting anomalies was not scientific skepticism. It was denial. The press conference was widely covered. News outlets around the world reported on Loeb's conclusions. The story was no longer just about an unusual interstellar object. It was about first contact, about the possibility that we were not alone, about evidence of extraterrestrial intelligence that had been hidden and was now being revealed through the work of independent scientists who refused to be silenced. NASA issued a response the same day. The agency restated its position. 3 I-Atlas was a natural object, and the claims being made by Dr. Loeb and others were not supported by rigorous analysis. But the response was brief, almost perfunctory. There was no detailed rebuttal, no presentation of alternative explanations, no release of the classified data that might have settled the question. Just a denial, stated with authority but backed by nothing more than institutional credibility. And for many, that credibility had been exhausted. The agency that had hidden data, that had issued misleading statements, that had pressured researchers to stay silent, no longer had the benefit of the doubt. When NASA said 3 I-Atlas was natural, people asked, "How do you know?" And when the agency did not provide evidence, when it simply reasserted its conclusion without supporting it, the denial lost its force. Public opinion shifted. Polls conducted in late December showed that a majority of people believed 3 I-Atlas was artificial and that governments were not being transparent about what had been discovered. The story became part of the cultural conversation, discussed not just in scientific circles but in mainstream media, in podcasts, in social media threads that reached millions of people. And through it all, the object itself continued its journey, moving outward through the solar system, growing fainter and more distant, carrying with it the answers to questions we were only beginning to ask. In January 2026, a team of researchers at MIT published a comprehensive analysis of the 241-bit message. They had spent months working on the decoding, applying techniques from information theory, cryptography, and mathematical linguistics, and they believed they had extracted the essential content. The message, they argued, was not a communication in the way we typically think of communication. It was not language, not a greeting, not an attempt to convey complex ideas. It was simpler than that. It was a beacon, a marker, a way of saying, "This object is artificial, and here is proof." The first part of the message, the 97-bit sequence that had repeated for weeks, was a recognition signal. It was structured in a way that could not occur naturally, a pattern designed to be noticed by any observer who was measuring the object's trajectory with sufficient precision. It was, in essence, a test. Are you paying attention? Are you capable of detecting small, periodic deviations from gravitational motion? If so, you will see this pattern, and when you see it, you will know to look for more. The second part, the 241-bit sequence, contained the actual content. And according to the MIT team, that content was a set of coordinates, not spatial coordinates indicating where the object came from, but temporal coordinates, a date and time encoded using a universal reference frame based on astronomical phenomena that any civilization would recognize. The coordinates pointed to a specific moment, the 21st of December, 2031, 6 years in the future, and a specific location in space, approximately 27 astronomical units from the Sun, in the direction of the constellation Aquarius. The message was not explaining where 3 I-Atlas had come from. It was telling us where it was going, or more precisely, it was telling us where and when something would happen, some event or arrival that we were meant to witness. The MIT team was careful not to overinterpret. They presented their decoding as one possible interpretation, acknowledging that other analyses might reach different conclusions. But if they were correct, if the message was indeed a set of coordinates pointing to a future event, then the implications were profound. Something was coming, or something was going to happen. And whoever had sent 3 I-Atlas had wanted to make sure we knew about it in advance. NASA did not comment on the MIT analysis. Neither did any other government agency. The silence was conspicuous, almost deliberate, as if acknowledging the decoding would give it credibility that authorities preferred to withhold. But others took it seriously. Observatories began planning campaigns to monitor the specified region of space in late 2031. Researchers discussed strategies for detecting whatever might appear at the predicted coordinates. And the public, now fully engaged with the story of Three Eye Atlas, waited to see if the message would prove true. 6 years is a long time. Long enough for skepticism to reassert itself, for the initial excitement to fade, for the story to drift from headlines into background noise. But it is not so long that people would forget. December 2031 was close enough to remain tangible, real, a date that could be marked on calendars and anticipated, and so the wait began. Astronomers would continue studying interstellar objects, searching for more visitors, more anomalies, more evidence of artificiality. Governments would continue monitoring, analyzing, deciding what to share and what to hide, and the rest of us would watch the sky, wondering what we would find when the date arrived and the coordinates were reached. Would there be another object, another visitor, arriving exactly when and where the message had predicted? Would it be larger, more obvious, designed not just to be noticed, but to make contact? Or would the coordinates point to something else entirely, some phenomenon or event that we had not anticipated and could not yet imagine? The only certainty was uncertainty. The only knowledge was that we did not know, and that perhaps, for the first time in human history, we had received a message from beyond our world and were being asked to respond. Not with signals or transmissions, but with attention, with observation, with the willingness to see what we were being shown. Through the spring of 2026, more details emerged about what had been hidden. Documents were leaked, released by whistleblowers within NASA and other agencies who felt that the public had a right to know what had been discovered. The documents confirmed much of what the independent network had found and revealed additional observations that had not been made public. High-resolution spectra showed absorption features consistent with titanium, aluminum, and silicon in configurations that suggested alloys or composite materials. Thermal imaging detected localized hotspots on the object's surface, regions that were warmer than their surroundings in ways that could not be explained by solar heating alone. And radar observations, conducted by planetary defense facilities designed to track potentially hazardous asteroids, had measured the object's shape with precision. It was not spherical. It was not irregular. It was cylindrical, with an aspect ratio of approximately 5:1, rotating slowly around its long axis once every 18 hours. The shape was strikingly similar to Oumuamua, the first interstellar visitor, which had also been elongated and cylindrical. Some researchers had argued that such shapes could form naturally through tidal forces or collisional processes, but the odds of two interstellar objects, detected just 8 years apart, both having such unusual geometries, were low. And when combined with all the other anomalies observed in Three Eye Atlas, the shape became another piece of evidence pointing toward artificiality. The leaked documents also revealed something else. NASA had not just been observing Three Eye Atlas. They had been attempting to communicate with it. During the period around perihelion, when the object was closest to Earth, radio signals had been transmitted from the Deep Space Network, powerful pulses at multiple frequencies designed to elicit a response. The transmissions had followed protocols developed for messaging extraterrestrial intelligence, including prime number sequences, mathematical constants, and simple pictorial representations. No response had been detected, or at least, no response had been publicly acknowledged. The documents described the transmission attempts but provided no details on whether anything had been received in return. This absence was telling. If nothing had come back, if the object had remained silent despite direct attempts at communication, the documents would have said so. The fact that they did not, the fact that the reception data was missing, suggested that something had been detected but was being kept classified. Speculation ran wild. Had Three Eye Atlas responded? Had it sent back signals, data, information that was now locked away in secure facilities and analyzed by teams operating under clearances that prevented disclosure? Or had it simply ignored the transmissions, treating them as unworthy of response, a primitive attempt at contact that did not meet whatever criteria it had been programmed to recognize? There was no way to know. The people who had the answers were not talking, And the rest of us were left to wonder what had been said, what had been heard, and what it meant for our understanding of where we stand in the universe. By the summer of 2026, the story of 3I Atlas had evolved into something larger than a single object or a single mystery. It had become a focal point for broader questions about transparency, about how information is controlled, about who gets to decide what the public should know. Congressional hearings were held, legislators demanding answers from NASA administrators about why data had been withheld and what justification existed for classifying observations of a natural phenomenon. The responses were careful, legalistic, citing national security considerations and the need to verify results before releasing potentially inflammatory information. But the explanations satisfied no one. National security was invoked, but no one could articulate what security risk was posed by an interstellar object passing through the solar system. Verification was cited, but the data had been held for months, long past any reasonable period for validation. The hearings produced no dramatic revelations, no smoking gun documents or confessions of malfeasance. But they reinforced the growing perception that something was being hidden, that the agencies responsible for space exploration were not operating with the transparency that their public funding and public mission demanded. International bodies also became involved. The United Nations Committee on the Peaceful Uses of Outer Space convened sessions to discuss protocols for handling potential contact with extraterrestrial intelligence. The discussions were abstract, hypothetical, focused on policy frameworks rather than specific cases, but everyone understood what they were really talking about. They were preparing for the possibility that 3I Atlas was just the beginning, that more objects would arrive, that the pattern of contact, if that's what this was, would continue and accelerate. And beneath the formal discussions, the diplomatic language, the carefully worded resolutions, there was a current of fear. Not fear of the objects themselves, not fear of invasion or harm, but fear of what it meant, what it said about our place and our insignificance. Fear that we were being observed, studied, perhaps assessed or judged by intelligences whose motives we could not fathom and whose capabilities we could not match. Fear that the universe was not empty, not waiting for us to explore and settle, but already occupied, already claimed, already shaped by civilizations that had been navigating the stars while we were still learning to make fire. Autumn arrived. The news cycle moved on. Other stories, other crises, other mysteries competed for attention. 3I Atlas remained a topic of interest in scientific circles, discussed in papers and conferences, analyzed in doctoral theses and research proposals. But for the general public, the intensity faded. The object was gone, too distant to observe, and the questions it raised were too vast and too uncertain to hold attention indefinitely. But some people did not forget. The Independent Observer Network continued operating, now expanded and formalized into a collaborative research organization with funding from private donors and scientific foundations. They monitored the sky, searching for new interstellar visitors, tracking objects that might exhibit anomalous behavior. They published their data openly, maintaining a public archive that anyone could access, ensuring that the mistakes of 3I Atlas would not be repeated, that future discoveries would not be hidden or controlled by institutions with conflicting interests. And they waited for December 2031, waited to see if the message decoded from 3I Atlas would prove accurate, if something would appear at the predicted coordinates, if the story would continue in ways that would answer the questions that had been raised or deepen the mystery even further. David Pritchard, the amateur astronomer in New Zealand who had first recognized the binary pattern in the object's accelerations, spoke for many when he was interviewed for a documentary about the discovery. He said, "We've been given a date and a location. Someone or something wanted us to look there at that time, so we will. And whatever we find, or don't find, will tell us something important. Either the message was real, and there's more to come, or it wasn't, and we've been chasing patterns that meant nothing. But either way, we'll know, and that's worth waiting for. In the quiet spaces between headlines and debates, in the private thoughts of those who had seen the data and understood its implications, a different conversation was happening. It was not about evidence or proof, not about whether 3I Atlas was natural or artificial. That question had been answered, at least for those willing to see the answer. The conversation was about what comes next. If an artificial object had passed through our solar system, if it had been sent by an intelligence capable of interstellar travel, then the fact that we detected it at all was significant. It meant we had reached a threshold, a level of technological capability and observational sophistication that allowed us to notice what we were being shown, and if we could notice one object, we would notice others. The universe, which had seemed empty, would begin to reveal itself as populated, active, full of signals and artifacts and evidence of minds that were not our own. This was not the contact scenario that had been imagined by generations of scientists and science fiction writers. There were no radio messages, no conversations across the light years, no exchanges of philosophy and mathematics and art. There were only objects, silent and enigmatic, moving through space on trajectories that hinted at purpose but offered no explanation. It was contact by breadcrumb, by clue, by puzzle, as if whoever was reaching out did not want to announce themselves directly, but wanted to be found, to be noticed by those who were paying attention. And perhaps that was the point. Perhaps the test was not whether we could build rockets or detect signals. The test was whether we could see what was in front of us, whether we could recognize artificiality when it appeared, whether we could overcome institutional inertia and secrecy and fear to acknowledge what we had found. By that measure, we had passed, barely, imperfectly, with delays and denials and bureaucratic resistance, but we had passed. The data had been collected, the patterns had been recognized, the message had been decoded, and now we knew, or at least we believed, that we were not alone. What we did with that knowledge, how we responded to the invitation embedded in the coordinates and the date, would determine what happened next. Whether we were ready for contact or still too fractured, too suspicious, too controlled by institutions that preferred ignorance to uncertainty, whether we could rise to the challenge of being a species that had been noticed and found worthy of further communication, or whether we would retreat into denial and distraction, letting the moment pass, waiting for someone else to take the lead. The months turned, winter became spring, spring became summer. The distant date of December 2031 grew imperceptibly closer, one day at a time, inevitable and patient. And in observatories around the world, preparations continued, telescope time was scheduled, observation campaigns were planned, instruments were calibrated and tested, ensuring readiness for whatever might appear at the coordinates that 3I Atlas had transmitted. Some researchers were skeptical. They noted that the decoding of the message was not definitive, that other interpretations were possible, that building expectations around a specific prediction was setting up for disappointment when nothing materialized. But others argued that even negative results would be informative. If nothing appeared, if the coordinates pointed to empty space and the date passed without event, that would tell us something about the message, about the limitations of our decoding, about the nature of whoever had sent 3I Atlas. And if something did appear, if the prediction proved accurate, then we would know that the message was real, that the intelligence behind it wanted to be understood, wanted to provide verifiable information that would establish credibility and open the door to deeper communication. Either way, the observation would be made, the data would be collected, and the story, which had begun with a faint streak on a survey image in October 2024, would continue into whatever future it was leading us toward. Late in 2026, a small but significant discovery was made. An astronomer at the Lowell Observatory in Arizona, reviewing archival images from years before 3I Atlas was discovered, found something unexpected. In images taken in 2019, There was a faint object, magnitude 23, moving slowly against the background stars. At the time, it had been catalogued as a distant main belt asteroid, too faint and too slow to warrant further attention. But when the astronomer calculated its trajectory and compared it to known objects, there was no match. The object's path, when extrapolated forward, brought it close to the orbit of 3I Atlas. Not identical, not the same trajectory, but close enough to suggest a relationship. And when the orbit was calculated backward, it traced to an origin in the same region of the sky, the same direction in Lyra, the same general area from which 3I Atlas had arrived. The implication was clear. There had been two objects, not one. And the second object, the one detected in 2019, had either preceded 3I Atlas or followed a parallel path. If it had preceded, if it had arrived years earlier, then it was possible that 3I Atlas was not the first artificial visitor, but the second or third. And if it had followed, if multiple objects were being sent along similar trajectories, then perhaps the stream was not over. Perhaps more would arrive in the years to come. The astronomer published a brief note in the International Astronomical Union circular presenting the detection and asking if anyone else had observed the object or could provide additional data. The response was immediate. Other researchers checked their archives, their databases, their logs, and several found similar detections, faint objects moving through the solar system in 2018, 2020, 2022, all with trajectories that pointed back to the same origin region, all too dim to have been studied in detail, all dismissed at the time as unremarkable. It appeared that 3I Atlas was not unique. It was part of a sequence, a series of objects passing through our solar system at intervals, moving on paths that were similar but not identical, as if they were following a pattern, a schedule, a plan. How many had there been? How many had gone unnoticed, too faint or too fast or simply unlucky in timing, arriving when no telescope was looking in the right direction? And how many more would come, in the years and decades ahead, continuing the pattern, continuing the message? No one could answer. The data was too fragmentary, the detections too sparse, but the pattern was undeniable. We were not seeing isolated events, random encounters with interstellar debris. We were seeing something intentional, something coordinated, something that had been ongoing for years and would likely continue. And the people who had been monitoring, who had been tracking and analyzing and trying to understand, began to realize that the story of 3I Atlas was not about a single object. It was about a campaign, a long-term effort to reach us, to be seen, to transmit information across the vast distances of interstellar space using the only method that was feasible: physical objects, traveling for millennia, arriving one by one, each carrying a fragment of a larger message. It was an intimidating thought that someone, somewhere, had decided to send objects to our solar system, that they had done so not recently, not in response to our radio signals or our first steps into space, but long ago, launching probes or beacons or whatever these objects were, timing their arrivals to coincide with an era when we would be capable of detecting them but still primitive enough to be cautious, uncertain, searching for understanding. What did they know about us? How had they predicted our development, our technology, our readiness to notice what they were sending? Or had they sent objects to thousands of systems, a broad casting of probes that would arrive across the galaxy at different times, waiting for any civilization that reached the threshold of awareness to see them and respond? The questions spiraled outward, each answer suggesting new uncertainties, new possibilities. But one thing seemed increasingly clear. We were not dealing with a one-time event, a chance encounter, an anomaly that could be studied and filed away. We were dealing with a process, an ongoing phenomenon that was unfolding around us, that we were part of whether we wanted to be or not. And the only choice we had was how to respond. whether to hide from what we were seeing, to classify and control and pretend that nothing had changed, or to embrace it, to acknowledge the reality, to prepare ourselves for whatever came next. As 2026 drew to a close, the Observer Network published a comprehensive report summarizing everything that had been learned about 3I Atlas and the other detected objects. The report was hundreds of pages long, filled with data tables, trajectory plots, spectroscopic analyses, statistical arguments. It was technical, rigorous, peer-reviewed by independent experts who had no institutional affiliations to protect. The conclusion was stated plainly in the abstract. Based on observational evidence collected over a multi-year period, we conclude with high confidence that Object 3I Atlas and related detections represent artificial constructs of non-terrestrial origin. The evidence includes trajectory modifications, inconsistent with natural forces, encoded patterns in the timing of non-gravitational accelerations, material properties not consistent with known natural formation processes, and statistical correlations between multiple objects, suggesting coordinated arrival schedules. We recommend immediate and sustained monitoring for additional interstellar objects and preparation for potential contact scenarios, including the predicted event in December 2031. The report was released openly, available for anyone to read, to critique, to verify. Major news outlets covered it, interviewing the authors, presenting the findings to a public that had grown weary of uncertainty and conflicting claims. And while skeptics remained, while official agencies continued to hedge and deflect, the weight of evidence had become too great to ignore. The consensus was shifting. Not universal, not unanimous, but shifting nonetheless, from doubt to acceptance, from rejection to curiosity, from fear to something more complex, a mixture of anticipation and apprehension and wonder at the implications of what we were discovering. We were not alone. And soon, if the message was correct, we would know more. The years that followed were years of preparation. Observatories expanded their interstellar object detection programs, installing new instruments, developing better algorithms, coordinating across institutions to ensure continuous sky coverage. Space agencies proposed missions to intercept and study future visitors, designing spacecraft that could rendezvous with fast-moving objects and conduct close-range observations. But these efforts were constrained by budgets and bureaucracy, by competing priorities and political realities. The world had not changed overnight. Governments still operated according to established interests. Resources were still allocated based on immediate needs rather than speculative possibilities. And while the evidence for artificial interstellar objects was compelling to many scientists, it remained controversial among policymakers who were reluctant to commit funding to programs based on interpretations that were not yet universally accepted. Progress was slow, incremental, measured in committee meetings and grant proposals and cautious statements that acknowledged possibilities without endorsing conclusions. It was frustrating to those who felt urgency, who believed that we were on the cusp of something transformative and that delay could mean missed opportunities. But it was the only way forward in a world that had not yet fully processed what it had learned. And beneath the official efforts, the private initiatives, the independent researchers who had been first to recognize the truth continued their work. They monitored the sky. They shared data. They refined their models and their predictions. And they prepared for December 2031, when the message would be tested and the next chapter would begin. In the quiet of observatories late at night, astronomers looked through eyepieces and at screens, watching the stars, tracking objects, measuring positions. They were doing what humans had done for millennia, observing the heavens, trying to understand what they saw. But now they were watching for something different, not comets or asteroids or natural phenomena. They were watching for visitors, for signals encoded in trajectories, for evidence that the universe was not silent, not empty, not indifferent to our existence. And sometimes, in the moments between observations, They wondered what it would be like when the contact became undeniable, when the evidence was so overwhelming that denial was no longer possible, when the world had to acknowledge that we had been found, that we had been noticed, that we were part of a larger community or network or pattern that extended beyond our small planet. Would it be frightening? Would it be inspiring? Would it change us, force us to reconsider our assumptions, our priorities, our conflicts? Or would we simply absorb it, integrate it into our existing narratives, and continue as before, slightly adjusted but fundamentally unchanged? No one knew. The future was unwritten, but the date was set, the 21st of December, 2031. Coordinates, 27 astronomical units from the Sun, direction Aquarius. The message had been received. The prediction had been made, and soon the answer would arrive. As the present moment fades into the background of this long narrative, as the immediate story of 3I Atlas gives way to the waiting period that stretches ahead, there is a question that lingers, unspoken, but persistent. What were they protecting? Who decided the public wasn't ready? The agencies that withheld data, that classified observations, that pressured researchers to stay silent, believed they were acting responsibly. They believed that releasing information about a potentially artificial interstellar object without complete understanding could cause panic, could generate wild speculation, could undermine public confidence in institutions. They believed that the responsible course was to study, to verify, to wait until certainty was achieved before making announcements that could not be retracted. But in doing so, they made a different choice. They chose control over transparency. They chose their judgment over public knowledge. They decided that they, and not the people they served, should determine what was true and what should be shared. And in making that choice, they revealed something about how power operates, how information is managed, how decisions are made in systems that are designed to protect themselves more than to serve the truth. They revealed that when faced with something extraordinary, something that challenges established understanding, the instinct is not to illuminate but to conceal, not to share but to hoard, not to trust but to guard. This is not malice. It is not conspiracy in the sense of deliberate evil or coordinated suppression. It is simply structure, the way institutions function when they encounter information that does not fit their frameworks, their narratives, their assumptions about what is possible and what is safe to acknowledge. But structure is not destiny. Systems can change. Institutions can adapt. And people, individual researchers and observers and citizens, can choose to act differently, to prioritize truth over control, to insist on transparency even when it is inconvenient or uncomfortable. The network of independent observers who tracked 3I Atlas, who shared data privately and then publicly, who refused to be silenced or intimidated, made that choice. They chose to look, to measure, to share what they found, regardless of the consequences. And in doing so, they ensured that the discovery would not be hidden, that the evidence would be available to anyone who wanted to examine it, that the story would be told even if official channels remained silent. This is the lesson, if there is one, of the 3I Atlas affair. Not that governments are corrupt, or that scientists are cowards, or that truth is always suppressed, but that truth requires effort, vigilance, the willingness to look beyond official statements and institutional pronouncements to the data itself, to the measurements, to the reality that persists regardless of how it is described or explained or ignored. There is a beauty in this, a quiet defiance in the act of observation. To point a telescope at the sky and measure the position of a faint object moving against the stars is an act of faith, a belief that the universe can be known, that patterns can be recognized, that meaning can be extracted from light that has traveled across unimaginable distances to reach our eyes. And when that act reveals something unexpected, something that challenges what we thought we knew, it becomes more than just science. It becomes a confrontation with mystery, a recognition that the universe is larger and stranger and more complex than our models predict. It becomes an invitation to humility, to wonder, to the acknowledgement that we do not yet understand what we are part of. 3I Atlas, whatever it was, wherever it came from, offered that invitation. It appeared in our sky, moved through our solar system, and transmitted a message that we were capable of detecting but not yet fully understanding. And in doing so, it told us that we were being watched, that we had been noticed, that our small planet and our brief existence were part of something larger. This is not a comfortable thought. It is not reassuring. But it is perhaps necessary, because we have spent our history believing that we are alone, that the universe is empty, that we are the protagonists of a story that has no other actors. And that belief has shaped our behavior, our priorities, our willingness to harm and exploit and dominate without concern for consequence. If we are not alone, if we are being observed, if our actions are being assessed by intelligences that we cannot control or predict, then we are forced to consider ourselves differently, not as conquerors or explorers, but as neighbors. Not as masters of the universe, but as one species among many, learning to navigate a cosmos that is already occupied, already ordered, already shaped by minds and wills and purposes that are not ours. And perhaps this is why the data was hidden, not because the truth was dangerous, but because it was inconvenient, because it required a shift in perspective that institutions built on dominance and control were not prepared to make. Because acknowledging that we were being watched, that we were not the center, that we were subjects rather than masters, undermined the narratives that had sustained empires and economies and ideologies for centuries. But the truth was always going to emerge. Objects were always going to arrive. Observers were always going to look. And sooner or later, someone was going to notice what was being shown and refuse to look away. 3I Atlas was the beginning, not of contact, not yet, but of awareness, of recognition, of the moment when we stopped being blind and started seeing what had always been there, waiting for us to develop eyes capable of perceiving it. Now we wait, 5 years and counting until December 2031, until the coordinates are reached and the prediction is tested, until we learn whether the message was real and what, if anything, will appear at the appointed time and place. The waiting is difficult. There is impatience, frustration, the desire to know now rather than later. But the waiting is also necessary. It gives us time to prepare, to think, to discuss what we will do if the prediction proves true. It gives us time to decide what kind of species we want to be when the next chapter begins. Will we be ready? Will we have learned the lessons of 3I Atlas, the importance of transparency and cooperation, the danger of secrecy and control? Will we have moved past the denials and the cover-ups to a place where information is shared openly and decisions are made collectively? Or will we repeat the same patterns, the same mistakes, the same reflexive impulse to hide what we do not understand and control what we cannot predict? The answer depends on choices that have not yet been made, on actions that have not yet been taken. The future is not written, but the date is set, and the message is clear. Something is coming, or something will happen, and we have been told where and when to look. What we do with that knowledge, how we respond to the invitation, will define us, not as individuals, but as a species. Not in this moment, but across the span of years and centuries that will follow. Truth was never what NASA feared. It was the moment everyone else finally saw it. The moment when control ended and understanding began. The moment when we stopped being alone in our own minds and became part of a larger conversation, a wider community, a universe that was watching us as much as we were watching it. And that moment is approaching, slowly, inevitably, one day at a time. The stars are waiting, the objects are arriving, and we finally are beginning to see.